Alright, so I did a bunch of these problems, and apparently I've been told there was no sound. And I think that was right, because when I went back and tried to play the videos, I didn't hear anything either. So let's do these problems again. The We should know that the basic properties for um, cosine. It has a period of 2 pi. It has an amplitude of 1. Um, it has a center line at y equals 0. It has a maximum value of 1 and a minimum value of negative 1. It's the basic shape of it is between, like I say, is between 1 and negative 1. And the graph starts at 0, 1, and its 5 basic points here are equally spaced, and it's crossing its center line at pi over 2, and at the next time it crosses its center line is at half of the period. So at any integer multiple of pi, um, now the max and min values are separated a whole period apart. 2 pi, the first maximum occurs here at 0, and if you go any complete cycle, the full length of the period, either direction, you'll be at the next max. Um, the minimum here is occurring at pi, and if you go to the right or to the left, a complete cycle, the length of the period, you'll be at the next min. So for the sine, we've got the same idea here. The period is 2 pi, the amplitude is 1, the center line is y equals 0, the max is 1, the min is negative 1. The basic um, graph has this shape. It looks like this. It's bouncing back and forth between negative 1 and positive 1, and it goes through the origin. And these 5 basic points that are equally spaced that we kind of use to sketch the graph. It's not super detailed, but it gives us a nice approximation. It's crossing the center line um, here at 0, and half of the cycle away, half the period away, and half of 2 pi is pi, and any integer multiple of that you'll be at the center line. For the maximum values, they're separated a full period apart. From here to here is 2 pi. The first one is occurring here at pi over 2. First one in this basic cycle, this primary cycle that we usually use. And then the minimum is occurring here at 3 pi over 4. And if you go to the next period, the next cycle, the distance is that period, which is 2 pi. So if you go any integer multiple of 2 pi, you'll be at the next min if you're starting at 3 pi over 4. All right, so now we have some transformations on this basic sine curve, but again, we'll reference this basic sine curve in going through and answering these. Our basic sine curve, we know, passes through the origin. The 5 primary points here are equally spaced. That has a period of 2 pi, a max and min of negative 1 and positive, min of negative 1 and a max of positive 1. This is pi over 2, and this is 3 pi over 2. So when we look here, the formula for the period is 2 pi divided by the coefficient in front of x, and this coefficient is 1/3. To divide by 1/3 is the same as to multiply by the reciprocal, so the period is 6 pi. And the amplitude is the number in front. We have to be careful that periods and amplitudes are distances, so take the absolute value. The amplitude of this is 1. Now, with this negative sign, it's not going to affect um, the where it crosses the center line. Let's continue with the center line here. This is a vertical shift down 4 units, so my center line is going to be at y equals -4. Um, since my amplitude is 1, my maximum value is 1 unit above that center line. -4 plus 1 is at -3. And 1 unit below this center line, -4 minus 1, is where the minimum is. But because of this reflection, we have to think in terms that the max and min have now switched places. The reflection across the x-axis didn't affect where the sine curve crosses the x-axis, crosses its center line, but it does affect the location of the max and the mins. Oh, I didn't answer where it crossed the center line. It crosses the center line here at the origin, and if you're half the period away, well, this time the period is 6 pi, half of 6 pi is 3 pi. So every time that we add an integer multiple of 3 pi to 0, then we're going to be at the center line, because you're going to be taking the sign of 0. All right, now if I want to be at the maximum, normally I would be thinking in terms of pi over 2, but now for maximum I'm thinking in terms of 3 pi over 2 because of the reflection. So this input into the sine function, this x over 3 plus 1, I need to replace it with 3 pi over 2 if I want to be at the maximum. So let's solve this for x. We've got x over 3 is equal to 3 pi over 2 minus 1, multiply everybody by 3, and we've got 9 pi over 2 minus 3. So this maximum value is 9 pi, occurs at 9 pi over 2 minus 3. And if you're a full cycle away, the length of that cycle, the period, is 6 pi. So if we have any integer multiple of 6 pi, we're just jumping, follow the bouncing ball along the maximum values of this, the graph of this transformation on sine. Now, for the minimum values, normally it'd be at 3 pi over 2, but because of the reflection, it's at pi over 2. So if this expression, if the input of this function were just pi over 2, then we would have the sine of pi over 2 is 1 times the -1. That's -1, and -1 minus 4 is -5. So we'll be at a minimum if we can find the value of x such that this causes this input to be pi over 2. So if we subtract 1 and multiply everybody by 3, we've got, if x is 3 pi over 2 minus 3, when you take the sign of that, you'll be at 1, and then -1 times 1 is -1 minus 4 is -5. Or if you're a full cycle away and the length of that cycle is the period 6 pi and any integer multiple of 6 pi. So there's our answers for number 9. Here we have the cosine. We don't have a reflection this time, so the reflections kind of make you pause and have to think a little bit. When you don't have them, you get used to your knowledge of the basic sine and cosine curve can make answering these kind of fast if you know what to look for. All right, so the period, the coefficient in front of x is 1, so the period is 2 pi. The amplitude is 5. The center line is the vertical shift, y equals 2. The maximum values, you're 5 units above your center line for a max of 7, and 5 units below the center line, 2 minus 5, at a minimum of -3. Now, we have a shift here, so the graph normally crosses the center curve at pi over 2. So if we're taking the cosine of pi over 2, we know that's 0, and we'd be 5 times 0 plus 2. So if we find the value of x such that x minus pi over 4 is equal to pi over 2, that input will cause us to be at the center line. So if we solve this for x, if we've got 3 pi over 4, and you're at the center line, if you're half the next half cycle, and if the cycle has a length, a period of 2 pi, then half of that is just pi. Any integer multiple of pi will just get you at the next center line. Now, the maximum value, cosine of 0 is 1, and 1 is a maximum value for the basic cosine curve. So if we can find the value of x, then when you plug it in, you get the cosine of 0. Well, that's pi over 4. Pi over 4 minus pi over 4. And that makes sense. We know that this is a shift to the right, pi over 4. So if you're at pi over 4, then you're at a maximum value. And maximums, the next maximum value is located a whole cycle away, and the length of that cycle is 2 pi, the period. So you're adding integer multiples of the period to that. The minimum values occur here at pi. The cosine of pi is -1, and 5 times -1 is -5, and -5 plus 2 is -3, and that's a minimum. So if we can just find the value of x that will cause us to take the cosine of pi, we'll be in business. If we add pi over 4 to each side, if x is 5 pi over 4, when you subtract 1 pi over 4, then you'll get pi. So if we input 5 pi over 4, we're taking the cosine of pi, which is -1. Positive 5 times -1 is -5, and -5 plus 2 is a -3. The next time that you're at a min is an entire cycle away, and the length of that cycle for this problem, is 2 pi. So there we go. There's our answers for number 10. And since I'm doing this the second time, I'm nervous now that I hope this is recording my voice. I don't want to have to do this a third time. There's a way to lay the track, an audio on top of something that you've already recorded, but I couldn't get that to work either, right? All right, so the period is 2 pi divided by the coefficient. The coefficient is pi over 2. So the pi's cancel, and to divide by 1/2 is the same as to multiply by the reciprocal. So the arithmetic there is just, if you punch that in your calculator and put parentheses around numerator and denominator, you can confirm that that's 4. The amplitude is 3. Both those are distances, and they're positive values, so we haven't made a silly sign error. The center line is the vertical shift of the graph of the basic parent function. That -7 is a vertical shift down 7 units. If we have a center line at -7 and an amplitude of 3 units above the center line, you'll be at your max. So -7 plus 3 is a -4. And 3 units below the center line, you'll be at a min. -7 minus 3 is a -10. Let's sketch our basic cosine curve so we can refer to it. We know that the basic cosine curve is between -1 and +1, that a starting point is up here at 0, 1, and these 5 primary points, major points, are equally spaced, and we complete a cycle here. This time, we know that for this graph it's 4. I've got to be careful. What I'm sketching over here, I almost started to sketch the new graph, is just the cosine. So, because I'm just using this as the starting point to apply these transformations. So I know that I'm crossing the center line if the input into this function is pi over 2. So that means that x is equal to 1. And I know that the next time it crosses its center line is half the cycle, half the length of the period. If the cycle has a period of 4, a length of 4, then half of that is 2, and any integer multiple of 2, and you'll be at crossing the center line. Maximum values of the cosine curve occur when, first one here, this primary cycle occurs when x is 0. So if I have an input of 0, well, the value of x that causes this to be 0 is 0. And if we're a full period away until we get to the next maximum, we're 4 pi, or no, not pi, just 4 away. And now for the minimum value, if I'm taking the cosine of pi, that's negative 1, and 3 times negative 1 is negative 3, and negative 3 minus 7 is a negative 10. So if I can just find the value of x such that this is pi, I'll be in business. So the pi's cancel, and if I multiply by 2, if x is equal to 2, then if you plug in x equals 2, you'll be taking the cosine of pi, which is negative 1, and then you'll get the negative 10. So x is 2, and the next time that this min occurs is a full cycle away. The length of the period, the length of the period is 4, and any integer multiple of 4. All right, so let's take a look at this guy. The period is 2 pi divided by the coefficient. That reduces to pi over 2. The amplitude is that multiplier out in front. Both of these need to be positive. Our center line is our vertical shift, and it's always y equals. Our max and min values are 7.7 units away from the center line. So if I'm at negative 5.3 and I go up this amplitude, up 7.7, I'll be at the max, a max of 2.4. And if I go from the center line, if I go down the length of the amplitude, then I'll be at the minimum, which is negative 13. Y equals negative 13. Alright, so let's sketch our basic cosine curve. It's between 1 and negative 1. And I've got this. Alright, so I know I'm crossing the center line if the input into this function is pi over 2. So if this, I need to find the value of x that will cause this algebraic expression to equal pi over 2, that I can substitute pi over 2 in. So to solve for x, I'll subtract 5, and then I'll divide everybody by 4, or multiply by 1/4. So if x is equal to this, when you plug it in, you'll be taking the cosine of pi over 2, which is 0, and you'll be at the center line, negative 5.3. And if you're any half a period away from that, that'll happen also. So let's move this out of our way a little bit. The half of pi over 2 is pi over 4. So if I'm pi over 4 units, or any integer multiple of that, I'll be crossing the center line. Now, I know that the cosine of 0 is 1, and 7.7 minus 5.3 is 2.4. I'll be at a 1. So if I can find the value of x such that this is 0, which is negative 5/4, then I'll be at a maximum output of this function. And we know that these max and mins are separated a whole cycle apart, and if the length of that cycle, the period is pi over 2, then if we have any integer multiple of pi over 2, we'll be at the next maximum value, whether you're moving to the right or to the left. So now if I want a minimum value, I don't want to have it take the cosine of 0. I want to actually take the cosine of pi. So let's come in and solve this for x. So we've got pi minus 5. If I divide everybody by 4, we've got pi divided by 4 and 5 divided by 4. So pi over 4 minus 5 over 4 plus, well, these min values are a full cycle apart, and the length of that cycle, the period, is pi over 2. So if I'm any integer multiple of pi over 2 away from this input, then I'll be at a minimum value. Alright, so I think this is the last one. Gosh, I can't remember. Yeah. Like I say, the first time I did this, I didn't have any sound, so I'm nervous that this is not going to have any sound either. The coefficient for, well, the last ones did though, because I checked it. 2 pi divided by 1 is just 2 pi. The amplitude is 4. There's a vertical shift of 3, so the center line is 3. 4 units above 3, you'll be at a maximum of 7. 4 units below 3, you'll be at a minimum of 3 minus 4, which is negative 1. The basic sine graph bounces back and forth between negative 1 and positive 1, and it goes through the origin, and these 5 basic points are equally spaced along the x-axis here. Alright, so we're crossing our center line for sine when the input is 0. So if we find the value of x, that we can replace x minus pi over 6 with 0. Well, hey, if you input pi over 6, pi over 6 minus pi over 6 is 0, and the sine of 0 is 0, and you've got 0 plus 3, which is 3, and you're at your center line. And you'll be at the center line the next time, half of a cycle away, and half of a cycle it has a length that's half of the period, and half of 2 pi is just pi, or any integer multiple of that. Now, what about maximum values? For sine curve, that's going to occur at pi over 2. So if we find the value of x, that this expression is equal to pi over 2, then we'll be in business. So if we add pi over 6 to each side, we'll get 4 pi over 6, which is 2 pi over 3. So if you input 2 pi over 3 minus pi over 6, then you'll get pi over 2, which is 1, and 4 times 1 is 4, and 4 plus 3 is 7. Or if you're a full period away, and the period here is 2 pi, an integer multiple of that. But what if we're at a minimum value? If we can find the value of x that you input into this such that we're at 3 pi over 2, alright, so if we add pi over 6, we'll be at 6 pi plus pi over 6, 7 pi over 6, no, that's not right. I didn't get enough sleep last night. 9, and 9 plus 1, hey, that's 10. And 10 over 6, that reduces to 5 pi over 3. That looks better. Alright, so the next time that we'll be at a minimum value is a full cycle away, which has a length of 2 pi. So that or any integer multiple of 2 pi will land us at another minimum value. So hey, I think that's it. I hope that helps. I hope this recorded, and I'll talk to you later. Bye.